Let me summarize how to sketch a polynomial function. The polynomial function. So, in general, the first step would be determine the end behavior. Step 2, we need to find zeros of this function. Of the function f. The third step, determine the multiplicity which will tell you the graph will touch or cross the x-intercept. Then the fourth step is collect all the information from the above 3 steps to sketch the graph. Let me use an example. Okay, but one thing is between the curve, between the zeros, we know just the curve will look like this one, but this may not be very accurate. If you want to have accurate behavior between the zeros, you may place some specific points, then connect these points with some smooth curves, then it will give you a much more accurate for the graph. But that would be enough. Okay, we just know somewhere it will turn down. Somewhere it will turn down. Okay, so now let's look at this example. F of x equals negative x to the cube plus 6x squared minus 9 over 2x. So this is a polynomial, right? Okay, so the first step 1, find the end behavior. So the end behavior will be like negative 2 times x cubed. So that is the leading term, right? The highest power term. So this one has the end behavior because x cubed is go up and go down here, right? But it's negative 1, so we will flip. So this one would be go up here and go down here. So this is end behavior. Step 2, find the zeros. How to find 0? You set f of x equals 0. So you will have negative 2x cubed plus 6x squared minus 9 over 2x equals 0. Okay, so to simplify this equation, since we have some fraction coefficient, so we want to eliminate this fraction, so we multiply 2 on both sides, right? It will not change nothing. It will change nothing. It's negative 4x cubed plus 12x minus 9x equals 0 times 2 equals 0. Okay, so now we take the common factor. The common factor is x, right? This here, sorry, here is x squared. X, so we always like the first term to be the positive number, a positive coefficient. So we have, okay, we take a negative x out. Maybe you can multiply negative 1 on both sides to make this one to be positive. That's okay. We take a negative x So it becomes 4x squared minus, this would be 12x plus 9 equals 0. And we notice that it's equal to, this parenthesis is actually a complete square, which is 2x minus 3 squared equals 0. Okay, so we have 0, which is 0, so x equals 0 is 0 for this polynomial function. X equals, this one equals 0, so it becomes x equals 3 over 2, right? Which are 0. So these are zeros. Step 3, we need to determine the multiplicity of the first 0, which is, we only have the power is 1, so here is 1. The second 0, the multiplicity of 3 over 2, which is, the power is 2 here, so it's the 2. Okay, so now, step 4, we just collect all the information we have. So when you draw the graph, first locate the zeros. 0 is here, and 3 over 2 is here, for example. We just need to sketch the graph, right? We don't need to be very accurate. So the graph, the end behavior, the end behavior will go up here, and the left is up, right is down. Okay, so up and down. So let's connect. We just use some smooth curve. So multiplicity is 1, goes through, cross. Multiplicity is 2, so we touch it. And go down. So this is the graph. So from this graph, for this part, when x is less than 0, f of x is what? Greater than 0. So we use the plus for this region. For this region, f of x is less than 0. And for this region, f of x is less than 0. Right. So the graph, why I introduced the greater than 0, less than 0, and it's positive or negative for each region. The reason is it's very important when we consider an inequality, polynomial inequalities.